На самом деле у меня была проблема, когда я изначально еще писал даже тизер в Facebook от презентации Magnus, потому что я, наверное, 3 раза предпринимал попытку его написать и бросал, потому что я не совсем понимал, о чем будет презентация. Вот, я прочитал несколько раз тезис Магнуса, несколько раз проконсультировался с Ильей, посмотрел даже саму презентацию с другой конференции, и, в общем-то, все равно были проблемы. Вот, поскольку как это очень необычная презентация на самом деле, она посвящена тому, как обманывать ваших менеджеров и показывать им данные, которых уже нет в базе, и при этом делать это на уровне базы данных, абсолютно никак не трогая приложение. Но концепция довольно необычная и для меня в чем-то новая, поскольку Магнус, в общем-то, рассказал об использовании такой функциональности, с которой я сам лично не сталкивался, и мне показалось это крайне интересным, и я надеюсь, что вы тоже это оцените, не стесняйтесь задавать Магнусу вопросы, уточнять что-то по ходу дела, потому что это такое мероприятие интересное и может потребовать серьезного погружения. Но, тем не менее, давайте представим слово Магнусу. Magnus, please.
I heard my name several times.
Yeah, I was just telling the guys that when I actually tried to announce your presentation on Facebook when we were publishing the teasers of our presentations, that I actually tried to do it a couple of times because I had a problem understanding what it is about because it's kind of complicated at first sight, but it's really curious and you showcase some features that I actually quite it's quite clever, but your approach to doing some things that seems quite impossible, and you do it kind of transparently on the level of the database. So that's basically what I was telling the guys about, and I give the word to you. So please, Magnus.
Okay, thank you. Well, I guess it's even good evening at this point, probably. At least good afternoon or something. This conference has a tendency to go on, and they also don't actually have an ending time today either. I just yapped at them about that because there's no ending time in the schedule, so I don't know how long my talk is about. Luckily, it's about time travel, so it doesn't really matter how long it is. We can just adapt to whichever needs. So for those of you who weren't here to see my presentation yesterday, my name is Magnus Hagander. I work on the Postgres core team. I also am one of the committers who supposedly writes code for the database. Not as much as I'd like, or not as, I don't know, maybe others would like me to write less code, I don't know, it depends on what you think of it, but that's sort of the general idea. I also work for Postgres Europe, arranging things like conferences in other parts of Europe. We don't actually work with this one, but I'm happy to be here to talk about that. When I don't work in the Postgres community, I work for a company called Red Pill Pro, which is an open source services business based in Scandinavia. I'm out of Stockholm in Sweden myself, where I sort of lead up our database efforts. And most of what comes in this talk is actually more or less directly from a customer project that we did. It's been edited for being allowed to be released and a few things like that, but that's sort of the basics. We needed to deal with an actual problem that seemed, as Roman said earlier, on the surface it seemed like that was not actually really doable, but we found a way to work around it. So what we're going to talk about is a TARDIS for your ORM. So let's start from the back. Who doesn't know what an ORM is? Okay, that's good. You all know what an ORM is. I would have been slightly worried if you had never heard of the concept of an ORM. Sorry?
What is TARDIS?
That was my next question. Who knows what a TARDIS is? Just a couple of you. That's a TARDIS, right? Who now knows what a TARDIS is? Well, come on, you all know it. It's right there. So a TARDIS in this case, for those, some of you will find it obvious, it's the time travel machine from Doctor Who. Hidden in, obviously, a police box. Where else would you put your time machine? Of course, we're not going to go into entirely that. You can probably find, the entire Doctor Who series online somewhere. Instead, what we're actually going to focus on here is basically what I'd like to call application level time travel. We used to have a feature in Postgres called time travel a long time ago, and it didn't really work that well, and it broke a lot of the generic cases. So eventually it was just removed in favor of being a good general database. But it's still a useful piece of functionality to be able to basically look at things the way they were in a different time. So we're going to try to implement that at the application level. But first, let's start with a step back, because as I said, this was a customer project. So we actually had some requirements, which, you know, we probably didn't fulfill quite all of them, but we got the important parts. The idea is that we have an existing application. In fact, there was a couple of existing applications on an existing database with existing data models and things like that. So one of the main requirements was don't change the data model, which is, you know, it made things a little bit harder, but don't change the data model, or at least change as little as possible, because there is a lot of legacy code, there are a lot of things like that still running against this. Now the data model contains, and the database contains, detailed and overview statistical data. So it's both things down to individual person and individual event levels, up to things that are like regional averages and things like that. And it contains highly sensitive personal information, which is one of the reasons I can't tell you exactly which kind of highly sensitive personal information it is, but it's at that level. So there are things to consider around that, and that's one of the reasons that made us sort of have to do this project in the first place. Now there are a few things that make it easier for us. One of them is that basically all the data is loaded into the system in batches, most of it, and then it's being manually corrected. Right? So we're getting batches of data coming in from other systems, and we then have actual people correcting it, and it's not that many of them. In particular, there's no high concurrency in this part of the system. There's high concurrency of people reading, but the people correcting them, it's, you know, it's a handful of people who make these corrections throughout. So yes, it's not zero concurrency, but it's not a huge level. And the core functionality of the system is building reports on this. So they do large aggregate reports across massive amounts of data, and smaller detailed reports, including the levels where they return sensitive information about individual persons, which is again sort of the core of the requirements around this. So these are the reports, and we need to make the existing reports just keep working, and we need to add some things to it. Now so far, this all sounds pretty standard, right? I'm sure you've heard of systems, you know, similar to this, requirements at these similar levels. Now there are a couple of things that make this a little bit harder. Number one, they have a requirement to be able to reproduce incorrect reports throughout all time. So basically, if we ran a report back in February, and then people have since fixed the incorrect data, we need to be able to reproduce the incorrect report as it looked in February. Which is kind of unusual. In most cases, if we correct the data, we want the corrected report. Of course, we want the corrected report as well. That's why we correct the data. But we need to be able to, at both the aggregate and the individual level, reproduce whatever incorrectness was in the data at, you know, any given point back in time. That's one of the challenges. Another one of the challenges is we need to be able to identify which reports during a certain time period contained identifiable information about a certain individual. So if I have an individual, I can say which reports ran in March that returned information about this person. Luckily for us, this part is not performance sensitive. Right? It's okay if it takes us a week to answer that question. The plan or the hope is to never have to do that, because this is covering the fact when you get a data leak. Right? We're covering the data leak, so we need to be able to track where a data leak came from. And it's okay if that takes some time, but it has to be possible. The next step of the challenges, we need to maintain application flexibility. And this is one of the parts that makes it really hard. Right? So there are a bunch of predefined reports. These are things we can easily deal with. This system is also used by statisticians, or I guess they're supposed to be called data scientists now, but not in this organization. They have manual query interfaces. They don't write raw SQL, but it's pretty close. And those things need to still work. And they need to not have to care about this, because they have like many copy-pasted reports and queries and things that already existed, and they need to keep running. But we need to be able to apply these other requirements to all those ad hoc reports. without changing the data model, and therefore, without more or less changing their queries. Again, there's never going to be a zero, right? Of course, there was a requirement that said 0 changes to the application. That's never going to work. We all know that. Like, it's not going to be 0. But we can get it down pretty low. So the core was to the challenge was to get these changes down to as low levels as possible. Try to make it so that the application developers don't need to care, and definitely make it so that the people who run the reports don't have to care, other than possibly saying, I want a drop-down field that says, I want the report as it looked in February. But other than that, they shouldn't need to put in extra join clauses or where clauses or things into their existing reports. So all that should just work transparently. And these are fairly challenging, but it's doable. Luckily, so our toolbox is the application itself is a JBoss Hibernate application. So Hibernate's the ORM in this case. Technology works for any ORM. Doesn't have to be Hibernate, doesn't have to be JBoss obviously. But again, they had the application. We could change that even if we wanted to. We can make small changes at the ORM level. Lucky for us, the database was Postgres. Of course, lucky for me, otherwise I wouldn't have been in the project and maybe someone else would have fixed it. But then I wouldn't have had to do this presentation, I would have had to figure something else. So basically JBoss Hibernate and Postgres. Whatever else is part of their stack is irrelevant to what we're doing here. The good thing about using an ORM, we can all say, who in here thinks ORMs are awesome and solve every problem in the world? Really? Okay. Who? I'm not going to say that. Don't do that. Yeah, I know. We all make mistakes. So who in here thinks ORMs are like evil and should never ever be used? Interestingly enough, the same person. We all know, ORMs have ups and downs, right? They're goods and bads. One thing that we gain by this is the fact that Hibernate generated the schema so the schema is simple. Right? Hibernate is not, actually as ORMs go, Hibernate is a fairly good one. But it doesn't generate really complicated schemas. They're all fairly simple. There are a lot of tables, but they're all simple. They use simple data types. There are no recursive relationships. None of those really complicated things. It's columns and values, so we can deal with that. It's all ORM generated. The downside, of course, is we need to be able to keep doing that. We can't actually change it too much. The other things that we get that help us is that Hibernate doesn't really care about schemas in the normal case, so everything is in public. That means that we can use all the other possible schema names to our own advantage. It also makes that every table has an ID column, because Hibernate requires that. Well, you can tag Hibernate to not use it for specific tables or things, but we have that. And we can make that a requirement from our side to the application, saying this will only work if you put all your stuff in public, this will only work if you have an ID column on every table. We don't actually care that the ID is a serial or that it's even an integer, but it has to be an ID column there, because we have to somehow be able to identify the rows. And there are also very few schema changes. Which helps us to the point that we did not actually build into the system the ability to handle schema changes. So if they go back and do alter table, they're simply not allowed to do that in an incompatible way. So we time travel across the data, but if they were to go in and do a drop column, we don't handle that. They're just going to have to keep the column and set it to null. If they want to change the data type in an incompatible way, they're just going to have to add another column. Now the schema is stable enough that they don't expect to basically do that. It's, the application itself has been stable for a while. So we don't expect a big problem there. There'll be some additions, those are easy to handle. So, how do we do this? Part of this, I'm sure many of you have done. Step one, keep track of all the old data, right? If we want to be able to reproduce old reports, we can't throw away the old data. Yes, that means we keep every version of every piece of data forever. Luckily, again, the bulk of the data comes in as batch loadings. There are some corrections made by people, means the corrections are fairly small. They are there. But we need to keep the old data, and we need to keep track of when that data was valid. during which times that data was valid. And I'm sure most of you have built, a solution for doing that. It's similar to like auditing or whatever you're doing. We need a history table. Who has never done anything using a history style table where you just sort of copy the rows and tag them with a date or something like that? Yeah, it's something we know how to do, right? Now the second question is, who knows about range types in Postgres? Good, most of you do, that's good. That's what we're also going to use. And that's one of the sort of secret ingredients that makes it possible to trick the ORM with all this. So basically what we're going to do is we're going to create a history table for every table. Yes, we automate this. And we're going to add a validity period, saying during which time is this particular version of this particular row valid. So basically we run something like this. We create a schema called history, and we just, for every table, we create one in there. So we say create table history.table1, in this case, rinse and repeat. We say like public.table1. It's the syntax for copy all the column definitions from public.table1. And then we add a column called underscore valid range that is of data type TS/TZ range, so timestamp with time zone range. The underscore is just to make sure we don't accidentally clash with, if there happened to be something called valid range in an existing table, we add an underscore. If there happened to be something called underscore valid range in an existing table, then we're going to have to change that. That did not happen. We did not have any of those. I don't actually think we had anyone called valid range either, but just to be on the safe side. In an ORM generated schema, you very seldom have table names with underscore as the first character. That tends to not be very happy in Java in this case. It works, but people don't do that. Quick reminder of the range types for those of you who haven't seen it. At the basics, a range type is just any type that it's a data type that has a start and a stop value, the first and the last value. For timestamps, it's very easy. It has a start and a stop time. We can have an integer range, which then has a low and a high number, things like that. So as an example, this is the format when we read range type. It comes out. You can see it says on the first one 2014-02-17 and a timestamp, and this comma and another timestamp. That means it starts at this first one and goes until the second one. Second row starts at this time and goes on until infinity. As you can see, the start of the range type has a square bracket and the end has a regular one. That's the range type's way of showing, is this an inclusive or an exclusive end? So the second range type is up to, but not including, this exact time. It starts at this exact time, including that time. Which means that if you sort of put two range types after another, make one of them inclusive and the other one exclusive, you get no gap and no overlap. Which is another part that we're going to use from this. So we construct these for every validity. It just says for each row, tell it when did it become valid and when did it stop being valid. Now, together with range types, we have another feature that we can use in Postgres to make sure that this doesn't happen. That's something called exclusion constraints. So let's keep doing the show of hands. Who has ever used an exclusion constraint? Okay, that's good. Exclusion constraint is basically like a unique constraint. I'm sure you've all used unique constraints. Where a unique constraint defines that there can be no equal values in this column in the table. An exclusion constraint tells you there can be no overlapping values. Now, if the column is a regular integer, that's actually the same thing. Two overlapping integers are by definition the same value. But for a range type, those are different things. Overlapping is certainly not the same as being the same range. So what we want to say is that for each individual row in our real table, there can be no overlapping validity periods, because that would be very strange. Then we could see two versions of the same row at the same time. So we do this by saying we take this history table, alter table history table 1, add constraint, give it a name, table 1 exclusion, it has to be unique. Exclude using gist, which is how we define the exclusion constraint. They always use gist. The other advantage of this is we also get a gist index, just like if you create a regular unique constraint, you get the B-tree index, and we will be using that when we do lookups. And then the syntax is ID with equals. That means for every case where the ID column is the same, this is where we add this requirement that there has to be an ID column. If there is no ID column, this wouldn't work. And then we just say valid range with double ampersand. Double ampersand is the overlaps operator for range types. So we're saying for each individual value of ID, there may be no overlapping ranges. And we can have multiple rows for each ID as long as they don't overlap. Now, this itself doesn't actually require an ID column. It requires something that's unique per row. But we could, if we have that different in every table, just building all these history tables and building what we're going to do later, which is the triggers to handle them, would just become really, really complicated and a lot of work. And the fact that Hibernate gives us this ID column makes life just a lot easier. Okay, so we have an exclusion constraint, we have our history table. The next thing we do is, of course, we need to capture the changes in the main tables and put them in the history table. For this, we use a trigger. We use one trigger that's going to work on all the tables. So for each table, we go in and say create trigger, table 1 history, before insert, update, or delete. These are the only operations we care about here. On the table 1, for each row, execute procedure history.log table trigger, which we're then going to write that does the interesting things. So every time someone does insert, update, or delete on the main tables, we're going to run the trigger, we're going to capture the changes, and we're going to put them in the history table. And what we're going to end up having here is we're going to have a table in public that contains all the current data. And we're going to have a table in history that contains all the historic data. So all we need to make sure is that that data gets copied over. So if we look at a cutoff, it's the real trigger is a little bit more complicated, but not too much. So when the trigger runs, we can check in Postgres the tg-op variable in our PGSQL function to see what type of trigger this was. So if it was an insert, then we're going to run this particular thing. And what we're doing here is we're inserting into history, and tg-rel-name will get populated with the name of the table that the trigger fired on. So we're going to insert into history and a table with the same name as the one we already had. And we're going to set select $1.star. It's going to take parameter 1, all the columns in parameter 1, which we specify down here to be new, which is the virtual table that contains the row that got inserted. And then we're going to add at the end. So first we insert all the tables, all the columns that we got from the master table, and then we're going to insert this valid period at the end. And we create that one by using the function tsTsetRange. There are multiple ways of creating a range type. If we just call the function tsTsetRange, we can give it parameters, it'll return a range type. We could also have a string and cast it into a range type, but this turns out to be the easiest thing here. So we say it's valid from the first parameter to tsTsetRange will be the lower end of the range. So we're saying it's valid from now. And it's valid until infinity. Because we just inserted it into the table, as long as nobody does anything, it's just going to stay there forever. And then in the final form we say the left-hand side, the beginning is inclusive and the end is exclusive. So it's valid until, but not including infinity. But infinity is a little bit special about that particular case. And then as a trigger we say return new. If we don't do that, the data doesn't go in the master table. And we still want it in the public table as well. So the insert part is pretty simple. The second part, what if someone updates a row? What if we got one of these corrections running? So we need to track the update operations. In this case, what we're simply doing here in the first step, well, the very first thing is we check if the operator is update. It's an update trigger. We open a cursor and read the valid range from this history table for the same ID as the updated row. That's the where ID equals $1. And we order it by the valid range descending limit 1. That basically means we get the latest version that's in the history for this row right now. And then we say for update to make sure we actually grab a lock on that row. And using new.id, so we get the ID from whatever row is being updated, and we look at that value in the history table. Then we make a check saying if this update would make the value empty. So we create a TSTZ range for the previous starting time and now. We're saying if we update it and it's empty, that means if somebody updated this within the same microsecond as we did, then we have a potential problem, right? Because we're tagging this by dates. So the first thing we do then, if that happened, we check, is the last XID, oh no, I forgot to fix a bug in my slides. So last XID is also being read back out in this query here. We get the XID of the last version.
Hopefully you fix the bug in the code.
Yeah, the bug was when I copied I simplified the function a little bit when I put it on the slides, and I simplified it just a little bit too much. So yeah, so last XID comes, it's not only valid range, but also Xmax. It's being read off the previous row. So what we say here is, if the last XID is the same, if the last XID is not the same, so if somebody else updated it within the same microsecond, then we just raise an exception and saying, sorry, this doesn't work. Now that's how we get away with it, because we don't have that much concurrency. As far as I know, this never fired, even during testing, we never managed to fire this, but it could happen. If we made the previous change as well, in the same transaction, and you would be surprised how often that happened. We did not have this check initially. We just assumed that each transaction would only run one update on each row, which would be each Java entity, but no. Sometimes they re-updated it multiple times. So what we do then is we just delete the previous entry, or delete from history where current of this one. So we remove the last history entry because we're going to write the new one. And that's going to be on the next slide. Yes?
Why don't you use defer trigger, a constraint defer trigger that would be fired one time per transaction at commit time?
We could use a defer trigger. It would be you would then not be able to query that data within, because the history entry wouldn't show up until the end of your transaction. You wouldn't be able to query the history data within your own transaction because you hadn't put it there yet, because the defer trigger fires at the end.
It would fix.
It would fix this particular problem, yes, but it would cause another problem.
And we would see the transition from beginning of transaction to the end of transaction for ID, for object, without transition during transaction.
Yeah.
Is it important to see the transition during transaction?
Yes.
Yes?
Yes, it was.
Okay.
But yes, deferred triggers would help with that particular case, while then making it impossible to query the history during, because it doesn't exist yet.
So with this thing, you are more or less kind of, every time it's updated, even if it's inside one transaction, you are putting new rows there.
If you update it multiple times in the same transaction, the second update, that's when we go delete the previous history entry from our own transaction and put a new one in. So at the end of the transaction, you will only have one history entry for that transaction, because it's a transaction. Right? So it either exists or it doesn't. Then what we do, so the else there, just to be clear, matches this one if it's not empty. So if we made an update and nobody else has been doing that same update, what we do is we go back and change the previous row. But the previous history row will always have a starting time and valid until infinity, right? That's the latest version. So we go in and change that. And we say for this latest row, which we get by the where current of, so for the latest row, go back and change the valid range. The start of the row's validity remains $1 here, which goes back to lower TT. So we don't change the start, but we change the end. So that this row is no longer valid until infinity, it is valid until now. Because we made an update, so the old version is no longer valid. But we're keeping it around.
Do you need lower?
Lower there, because it points to the range type. We need to copy the starting time of the range type to the starting time of the new range type. So lower on a range type gives you the lower end, and upper gives you the end of the range. Yes?
Will those now and below now values be the same in this block?
The now value will be the same, yes. Because the now value is the transaction time. If you used, what is it, clock timestamp? Clock timestamp, then they would not be the same, and then you would get gaps in the validity that would cause big problems. It took me a short while to convince some of our Java guys that yes, that is actually the transaction time. That's not going to happen. Yes?
Excuse me, you are using ranges, but why not just 2 columns?
Well, for one thing, we couldn't do the exclusion constraint. And you're going to see it when we get a little bit further, when we're querying this data, that the ranges makes a lot of other things much, much easier. This part, you could do with 2 columns, except you would not get the overlaps check. Okay, so what we do then is we insert into the history the current version of the row. So we get a new entry, which gets everything valid from now until infinity. So we update the validity what was there previously to stop being valid now, create a new one that's valid from now until infinity, and we use the fact that the top one here ends exclusively, and the new one begins inclusively, so that there is no gap in between them. We just switch which version is valid. And of course, again, return new, otherwise the update doesn't actually happen. That would be boring. Final type of check, as always in these systems, delete and updates are very similar, but we need to track them. So in delete, we do the same thing. With the same copy and paste error, it's supposed to read out the Xmax here as well. The previous range, how long is it valid? Read it back. Has this row already been updated in my transaction, but then I deleted it? In that case, go back and delete the previous update that I made in my own transaction. There is a similar XID check here that I just took out of the slides to make them a little bit easier to read. And the same race exception if somebody else updated it within the same microsecond. And then instead of writing a new validity time, we go back and change the last row. So when we do delete, we end up doing an update of the last row in the history table, and we change the validity where the start is still the same as before. $1 there goes back to lower, but instead of being valid until infinity, it is valid until now, because we just deleted it. So in the future, it's gone. And at this point, we say return old. That's just how the triggers work. It's no longer return new. When it's a delete, it's return old. At this point, the row will be gone from the main table in public, but all the history rows remain in the history table. So we have all the old data, and we can query and access all the old data. So we fixed one of our problems. We can now track all the data. And accessing this is pretty simple. If we want to access from the history table at a specific time, we just say something, in this case, select ID ABC from history.table1, where ID equals 42, which happens to be the row I'm looking at, and valid range, and then you have the @ sign greater than, which is the range type containment operator. So if you give me the row where this timestamp here is contained within the range. And yes, there is another nice set of typos in my slide, which is all the data was 2014 and the test was 2015. But let's try to pretend that wasn't so. I have 2 sets of test data and I use both of them. This query will use the gist index that we just created, so it will actually be very fast, even if you have billions of rows in your history table. As long as the ID column is in there, it will be really fast. You can get reasonable searches on the range as well, but if you're going to end up returning the whole table, it'll eventually get slow. So we could just rewrite all our queries to do this. and now we're done. Except, that doesn't really fall under the minimum modifications if we rewrite all our queries. But for the change tracking, we have to change exactly nothing. Right? None of our updates, insert, deletes have to change. None of the batch loads, all that stuff works. But try to take a 9, 10, 12-way join and add these checks to every part of it, make that work, and try to see if the guys running these statistics reports are happy, because they're not. Because we have to put this valid range check on every single table. So if we join 10 tables, we need to put 10 of those checks in there. So let's see if we can fix that. Now is when we get to the actual important part of this, right? We need a schema called time travel. Everybody needs a schema called time travel. And what we're then going to do is auto-generate for each table in the time travel schema, we generate a view. And the view is going to look like this. We actually have to get the column names out to get this to work well. But we say create view time travel.table1 as select, and we list all the columns except valid range. Valid range is not included here because you don't want to expose the valid range to the application, because the ORM can get confused if it queries for column, or if it gets back columns that it didn't know existed. And we read from the history.table1. And we just add a where valid range, again, the containment operator, and instead of putting a constant in there, we read a config value. So you just read the setting, the current value of the setting history.timestamp. And then, we have to cast it twice. That's just how it works. So we cast it to text, return value, cast it to timestamp with time zone. And now for whatever value I put of that, we can actually do time travel. So we have one setting. And if we change this setting, the view of our entire database shifts to that point in time. And that does actually work. And then we flip the schema search order to turn on and off time travel, which we can also do without Hibernate realizing it, because it doesn't know what the schema is. So really doing basic time travel, in PSQL you set the search path to time travel, so that it will pick the views. You set your history.timestamp to whatever time you want to look at the database, and you run a select. And that will give you what the database looked like at 2015, 03, 07 at 1432.
In your current time zone?
In my current time zone, yes. Now we're using timestamp with time zone, so it would actually work across time zones. As far as I know, all their data is in the same time zone. But it will deal with annoying things like daylight savings time, which unfortunately we have lots of.
Now,
actually, I think the timestamp should be removed from the database completely and added there only by special extension, because this type spoils so many things, and so many systems are written wrongly because of this.
Yeah, I agree.
Local time. It's catastrophe.
It makes assumptions that are just it's crazy. Like time doesn't actually exist without a time zone. We have defined it that way. And then if I go, so here for the same table, the first select is the same one I did before. If I just change my history to timestamp, do a select, I'll get however it looked. In this case, was it 3 minutes earlier? So 32 it looked like that, at 29 it looked like that.
And if the variable is not defined?
If the variable is not defined and you query from history.times, if you query from the time travel schema, you get an error.
Rise exception.
Yeah, well, you get, the database will just say there is no value for this function. But as an optimization, we make sure that if the application wants to look at the current data, we always look at the public schema. But that's a pure optimization. We don't actually need to store any data in the public schema. We can run the whole thing off the history tables. But it's still the majority of all queries are still going to be against the current values. So we basically cache them in the public schema. So at this point we've reached sort of a time where we can make automatic time travel. It surprised me how well it performed. Even when you do like joins across historic data, it just works. We need to do like some custom indexing to make it really fast. We couldn't automate that because we don't know the data model that well. But it gets pretty far. And all we need to do is inject the search path and the history timestamp setting somewhere in the application. The rest of the application remains unchanged. So now we've at least reached the point, it's not 0 changes, but this qualified in under minimal changes. It's not that much. Exactly how you do it is going to depend completely on the framework. Right? It might be a driver level thing, you might wrap your queries. It might be just a function call, so that instead of running a query, you explicitly say, time travel this query. We tried a few different ones. I think the one I think more than one is actually in use. But the main one for most of the web-based app is basically wrapping the JDBC driver of Postgres. We create our own JDBC driver that inherits from the Postgres JDBC driver and simply adds the ability to do inject time travel. This is obviously very redacted code. It's a little bit more than that, but I think the whole thing, including all the interfaces, is like 200 lines of Java or something like that, which is 100 lines of curly braces and 100 lines of actual code. So it's not particularly hard. Just trap the connection in this point where it gets it from the connection pool and inject these variables.
They can manage, so they have additional methods on the connection.
Yeah, exactly. Like this inject time travel, which will then pick it out of. So this part, as you can probably tell from how clear I am about this, someone else wrote this. I don't do Java development, particularly I don't do Java enterprise development. So yes, at some place they picked up the time and they injected it, and it ended up in there. But that's at the application level. You have to somehow figure out how to get these two things in there: search path and history.time travel. And once you set those, the rest become transparent. There are a few things to think about. For example, don't forget to reset this thing. In particular in connection pooling, really funny things happen otherwise. When you test it and one session sets time travel to something and someone else thinks they're running in current and get the connection back and get old data, it can be confusing. We had some issues around that, which I think is one of the reasons we ended up eventually putting it at the driver level, because they could pick it up and just forcibly reset it even when the application didn't do the right thing. It's much easier if you don't do connection pooling. Right? So it depends on what kind of application you have. If you only run very few queries, you don't need connection pooling, that problem goes away. And we also explicitly wanted them to query the public schema for the current data, purely as a performance improvement. We can query it. If we set the timestamp to now and query the history schema, it works. But we have to scan the relevant ranges, so obviously it's going to be a bit slower. And again, it's actually surprisingly good performance. So that solved most of our requirements. There's one really difficult requirement left. What about this thing, identify which report contained a specific person? Does anyone have an actual good idea for how to fix this problem? Because our solution is not pretty. Does anyone have a suggestion for how to do this in a pretty way? Suggestion? Or? I don't think we have an well, we're not that big. You can get a microphone or you can just yell.
So we can just take a record of each report we export to, say, consumers. So each and every report that is generated, we pass it to our security team that stores it in a secure way, so we can apply some public search. That's it.
Yeah, we could do that. We could take the result of every report and store it somewhere, and then be able to query that. Someone did a projection on the storage requirements for that, and that was way over our budget by orders of magnitude, because some of these reports are very large. So yes, that could have worked, but it didn't work in this case. And it's not a particularly elegant solution. On the other hand, neither is ours. Any other good suggestions?
You build the reverse index on the IDs in every...
Yeah, and so store that back. That's also very hard to do transparently.
So, 1 second, what do you want to do? So, transparently. So you want to be able to...
I want to be able to go in and say, basically, data was leaked about Joe in sometime in February. Who ran the reports that gave that data back?
What about giving permission to run the report?
Yeah, well, this includes ad hoc queries.
Can you just log all the queries along timestamps and usernames? So
Yes, that's exactly what you can do. It's not very pretty, but it works. That's exactly what we do. Right? We log all the select queries coming out of that part of the system. And basically, to identify it, we rerun the reports with time travel and see if Joe showed up. Which is when I say, yes, this takes a lot of time, but the requirements were like, yeah, if it takes a week, it's not a problem. Over?
So you were saying initially that when you were to edit previous data, you wanted to preserve the original contents in the report. Did you address that already?
Yeah, that's the time travel. So if you update, if you fix the reports, if you fix the data, and then you rerun the report setting time travel to the previous date, you get the same bad data that you got before.
Oh, okay. No, I thought you were talking about fixing historical data.
No. So, well,
oh,
it's a matter of you fix the date at this point. That's when the unfixed becomes historical.
Okay.
Yeah. No, we don't support like forking the timeline sometime back in time.
So couldn't you just use overlapping of the time to get all the records that contain the person you're looking for, instead of? Yeah.
No, I can get the records, but for this requirement, I need to know which reports, not which records. So I need to know who ran the reports that ended up leaking the data about Joe.
Okay.
Now, if it was just the records, then it would be much easier.
Actually, your solution is not kind of it's wonderful. It's not bad, because it's not only to find the things who leaked information about Joe, but also to find out who searched for something else.
No, it can also be who searched for Joe without having the rights to do that, or something like that.
For all the documents that contain something else.
Yeah, exactly. Yeah, you can go back for those things as well. The requirements didn't stipulate that, but yes, that would work as well.
Because otherwise, all other specific solutions that would kind of concentrate on user IDs would kind of build some kind of catalogs.
Yeah.
And so on. So, wonderful solution.
So it does. It feels kind of ugly. I wish I could think of a better way, but this actually works, and it works well enough, and I can't really think of a cleaner way that does that without adding like ridiculously massive storage requirements.
But don't audit requirements actually require to kind of log every query anyway? No.
It didn't. But the overlap with those audit requirements is pretty big for this solution, which, again, it means the extra overhead cost of doing this is not that big. And we also, like in the actual, there are some very rough tools, because again, we hope this will never be used. There's some rough tools that know some heuristics that can just, we don't have to rerun every query. We can exclude like known patterns that we know will never contain these personally identifiable information, for example. We can just bypass all of those. And we really need to track specific reports and the ad hoc queries.
What you really need would be like a trigger that fires on select.
Yeah, well, the problem with the trigger that fires on select is that I have to store the data somewhere. That's a lot of data.
What if you just stored the IDs that came out of that report as an array?
That could work, but as Valentin said, then you're locked to, you can only look for those IDs.
Sure.
If you suddenly come up with different things that you want to figure out who looked at what, then you got nothing.
Right.
Yeah. Got a microphone in the back again?
The question regarding performance, did you test joins over historical data?
Yeah.
How does it work actually? I believe it won't fly. So provided you have it lookup by ID, that works. Okay.
Yeah.
But when you go the other way around, you just query by last name, whatever field there is. How does it work?
So the joins end up being on the ID, right? So the join, you can use the gist index for the join. And then we did have to go back for like specific history tables and add indexes to do those lookups. And that was something that we had to basically do that manually, because we couldn't do the historic lookup, like we'd end up with too many indexes if we just did everything.
So you more or less replicated the indexes on the original tables to the historic tables as well, more or less?
Yeah, more or less. Far from all of them, because it depended on sort of what kind of data you looked at. If you replicated all of them, that became just unnecessary overhead. But yes, we had to sort of replicate those levels of indexes.
Sorry, but the query of select all the orders for given customer is not selected by primary key. So, did you have such queries? I guess you should.
Yeah, this is where we had to create secondary indexes on the history tables as well. And they will support...
That will blow up, right?
Sorry?
Do you use gist for all the indexes?
No.
So you select all the rows and you have to filter.
Yeah.
Lots of I/O, lots of...
In some of the cases, we would use a gist index with the validity range in it, so you'd go directly there. In some, we might have just an index on the character field, and it's based on the fact we don't, like, the number of records for each entry in the history, or sorry, the number of entries for each ID in the history table is not large, like it's not into the thousands in any case. There are never that many updates to an entity. It's like the top one has like 15 or 20 updates. So if we can look it up with the other index, and then we'll just sequentially scan those 20 to find the latest one.
Is it possible to build something like partitioning on range table or range column?
Yeah. Yeah, you can.
Did you use it?
No, we didn't actually, because we reserve the right to do that in the future, sort of. We haven't had the need yet. None of the tables have become that big. Like there's a couple of 100 million rows in the largest history table, I think, which is not enough to bother with partitioning yet. We're also going to see if we can do something interesting with, upcoming brain index and thing in the future, just to not have to partition it. But so far we haven't had the need for it, but it can be done if you have to.
It's the same trigger.
Yeah, basically you can put that in that trigger to steer it off to individual partitions.
I have two questions. So one is, changing of structure. So kind of, do you have any triggers that kind of expand the history tables depending on the changes in the original?
No, we don't. We deal with that manually. We could do that, but then it would be really hard to make it entirely transparent for Hibernate.
But you could change view from...
but insert...
Yeah, but if you go through JSON-B, you lose data types.
You can use DDO event triggers.
You can,
yeah, we could use things like DDL event triggers or whatever to capture it, but I'm sure we could. It would be a complicated thing to do, and we didn't really have to. We have simple things. It's sort of like, for those of us who've ever used Slowly, just remember to run your DDL changes through a script, right? But basically, the only DDL changes that we really care about are additions of column. It's really the main thing they do every now and then, or new tables. But new tables are easy. We just rerun the script to create the history table. And for additions of a column, we just have them basically do that manually. Add the column and set it to null all the way back in time. So we don't do time travel of the actual structure. If you query the table as it looked like last year, it will include all the columns that exist now. They're just null.
Another question, the performance kind of impact of this trigger. So these triggers are constantly using execute. So and you're building insert statements more or less. So I also was searching for something better, but I couldn't find it. So it's kind of, it looks like it's the only way to insert something into kind of...
Yeah, if you want to add something to it, or modify it, or...
Yeah, so it's kind of, have you measured it, or do you imagine some better way to do it without?
Write it and see.
Yeah, write it and see. No, I mean we ran a lot of performance, and the overhead on the update side was surprisingly low. Probably because, you know, as in most cases, that thing was limited by number of commits anyway, and it doesn't change the number of commits. It's just more updates within the same transaction. I was actually surprised how fast many of the historical queries were. But obviously, historical queries are slower than queries right now. But, you know, that's the price you pay, because we're querying much more data. Okay, yes?
Thank you for your solution, it's elegant. I'm surprised today I became to love schemas. What I have a note about index creation on when you don't use range types but using separate columns instead. You indeed can create exclusion constraint. Just when you're creating, you type tested as a range and the name of columns, and it works.
Well, yeah, you can create a functional exclusion constraint. Yes.
Yes.
So you can, instead of creating an index on, you know, start, comma, stop, you create the gist index on TZ range of start, comma, stop. Yes, you can do that. But then on the other hand, you're already using the range type, so you can just use the range type all the way.
We're using ORM too, and it's inconvenient to use range columns from ORM.
Yeah, no, I can see the point of that. In this case, we're never showing the range types into the ORM. We're hiding them behind the view, so the ORM never sees them. But yes, if your ORM doesn't support range types, you can still do a few things. You're also going to have to tweak all your queries in order to use the index for the lookup.
Oh, thank you.
So, thank you. One more note of things that we actually managed to get spectacularly results with is if you have ORM level caching. No, individual entities in Java in this case got cached at different timestamps. That confused the hell out of a lot of the system. Whether it's a query or it's an entity, so it's not entirely transparent. You have to, well, in our case, just turn that off. Like query caching at the application level tends to be dangerous. And since we're trying to hide this whole time travel, if the application caches the actual objects and then runs the query a couple of times at different timestamps, they just show up at basically random relations. So just, you know, don't do that. It's as simple as that. It has to be aware. If you cache it, you have to put the timestamp, the time travel point into the hash key for what you're caching. If you do that, it works. But then you have to hack up the cache, which is not that hard to do. But it has to be done. So basically, a few conclusion of that is I'd like to say range types are awesome. Like really, if you're not using them, you can probably find some use case for them, and then you will find more. That's sort of how I thought. Initially, when you looked at them, it was like, yeah, this looks like kind of a neat feature. Once you start using them, you just see more and more use cases where they can be really, really useful. And it turns out that ORMs, like the fact that ORMs are fairly simplistic in what they do, because they're designed to be that, means we can trick them and do really cool things without having to make large changes to, you know, legacy code bases. And it really pays off. We had a round of discussions with the customers initially because they wanted initially a solution that was database independent and did not require application level changes. And eventually we managed to convince them that, well, first of all, that's just never going to work. And actually, if you want to build a little bit more complicated solutions, don't even try to build them database independent, because that means least common denominator. Like you're throwing out all the good features of all the databases. If you're building that, if you happen to be deploying an Oracle and you're building database independent, you have to throw out a lot of the good stuff in Oracle too, right? Because others might not have it. So build for whatever platform you're planning to do. You can use all the flexibility and all the power of the engine. That'll just make your life so much easier in a lot of ways. That's it. Any more questions?
Just one.
Yes.
Just a theoretical question. Could things like this be done on lower level? Because Postgres is multi-versionic, so...
Yes, yes it could. Could it be done on the lower level? Yes, it could. Was it done at the lower level in the old time travel that we had in Postgres? Yes, it was. Now the implementation there wasn't too good, and it turned out, if I remember correctly, Bruce, do you remember how the old time travel code worked?
Yes.
It was basically, we just never vacuumed, right?
Yeah.
More or less. We kept all the old versions around, and you could move back by time into those.
Invisible columns, system columns.
Yeah.
And you use that, and in the where clause, you'd say table name, and then you put brackets of what time you wanted to see that table.
Yeah. So it's relatively close. There is support in the SQL standard for this, for time travel these days. I think only DB2 implements it. Oracle does it too, in the same syntax?
No, that's not the same syntax.
Yeah, Oracle has the ability to do it, but DB2 is the only one that follows the standard. And, I mean, no offense to the DB2 people, sorry, is there someone else who follows the standard?
Yeah, there is a standard, the new one, and Oracle does follow it. So Oracle 12 follows the standard for time travel, and that's it.
Either way, I was going to say that the standard is really crappy. And it's copied from DB2, that's why they were the first one to support it. I see Oracle supports it too. It's, for example, it assumes that such neatness as range types don't exist. Like the start and stop time has to be in 2 regular columns for this to work, which is kind of ridiculous. And the way you query it is also kind of strange. There are some good things to it. It would certainly not be bad if we could sort of retrofit that on top of Postgres. It would be much more limited than what we can do today, but we could support the standard syntax. We don't do that now, and the old Postgres time travel certainly had a very different syntax. But the general idea in the standard is you can just take your general query and say, show me as of timestamp. And that's supposed to just work transparently. It doesn't really work transparently even in the systems that support it, but it gets pretty close. But we don't do that now. But yes, we could certainly implement it at a lower level so that you don't have to do that. We could possibly could get lower overhead from doing that. But it's not something we have today.
Actually, we're out of time.
We're out of time, good. Then I give this to you.
Okay. One question.
Very short.
There is one sorry, I talked to you.
Yeah, sure, we can take the question after.
Yeah. That's a good idea because in our case security throw us out in 5 minutes, something like that.
Well, thank you all for risking getting caught by security.
Yes. So let's thank Magnus. And we see all of you tomorrow for another 2 pretty nice tracks of talks. So, welcome.